Let's use the for loop to solve some of the problems we've solved earlier using while loops. The first one we'll work on is the problem where we have a beginning balance and a given annual interest rate and a number of years to calculate and figure out what that investment will be worth after that period of time. So we start off by declaring our variables, double balance and rate. We'll need the number of years we want to calculate on. We prompt the user for the beginning balance. Prompt the user for the annual interest rate. Finally, prompt the user for how many years they want to calculate. And now we're ready to write the for loop. So we'll say for int I equals 1. Our relational expression will be I less than or equal to years, so that we compute right up to the number of years prompted for. Our modification is increment I by 1 each time through the loop. Now we compute the new balance, and we're finished. All we have to do is display the results. And we're set to go. Let's build and run the program. 1000, 1.02. We'll do it for 10 years. And if you recall, after 10 years, that balance at 2% interest is $1,218.99, which is what we got before. So you see, we're saving ourselves a few lines of code. Semantically, or as far as the meaning of the program goes, it really hasn't changed from the while loop we wrote before. For loops just provide a more concise way to write count-controlled loops. Let's look at another example. Let's do the multiplication example we did earlier where you only have addition to work with. So we'll comment out the code from our interest rate calculation. For this problem, we had some variables num1, num2, product, and count. This time we don't need count, so we'll stop with product. We'll initialize our product to 0, as we did before. Let's prompt the user to enter the numbers. Prompt the user for the second number. Get it from the keyboard. Now we're ready to compute. So, for loop for int I equals 1, while I is less than or equal to num1 plus I. Open the loop body. Product plus equal num2. Close the body. Display the result. Now we're ready to build and run. First number we'll do the same set we did before, 5 and 3. And the result is 15. Again, the for loop is just another way to write a count-controlled loop where we know our beginning and ending boundaries and how many times we want to iterate through the loop. Another set of problems that lend themselves to for loops are problems that involve tabular data. In my next video, we'll talk about how to compute tabular data using something called the nested for loop.